So, before we jump into compound inequalities, what is an inequality?
Something that is not equal.
Yeah, it's not the equal sign. So when you talk about inequalities, you got a few options. There's that one and that one. What are those two called?
Alligator.
Those are not called alligators. You failed art, didn't you? This one is less than. And this one is less than or equal to. Okay, then we got these two. This one is greater than, which means his friend next door is greater than or equal to. And one of my favorites is this one. What do you suppose that one is? Not equal to. We aren't going to actually use not equal to this evening, but just for the sake of completeness, I'm going to go ahead and put it on there so that you've got them all at your disposal, all of the inequalities that we're going to be talking about. So one of the things that you need to know is what an inequality is. And the other thing you need to know is what is meant by compound. So I'm going to take a little detour here. It's going to sound like I'm ignoring compound, but I promise I'm not. Let's do a quick little review of sets. This is going to originally look like I have lost my mind and I'm on a different topic, but I promise we're looping back around. Sets. Sets are exactly what they sound like. They're sets of numbers or groups of numbers. So let me give you two sets here. Let's say I have set A. This is from last semester, so I'm not going to spend too much time going over this. X such that X is an odd number. Let's say greater than 0 but less than 10. So what numbers would be in set A? Just say them out loud. What would the numbers be? The odd numbers that are greater than 0 but less than 10.
3, 5.
3, 5, 7, 9, 1. Good. And then B, we'll have a set B. That one's going to have the numbers 1, 2, 3, and 4 in it. So set notation looks like this. It just means groups of numbers. Okay. Now, here's where I'm going to get to the compound part. You may recall from last semester, and if you don't, you should write a strongly worded letter of complaint to your algebra teacher last semester. This symbol. Who, for $1 million, remembers what that symbol means?
It's on the graph. It's like a new graph, right?
Go way back.
Huh?
Has something to do with the numerator, but I don't remember.
It does not have anything to do with the numerator. This symbol right here means intersection.
Are you sure we learned that last semester?
100% sure. And what this means is the numbers in this case, I'm going to say they're called elements because they don't have to be numbers. The elements that are in both sets, so that are in A and B. So if I were to ask you what A and B is, A intersect B or what have you, if I were to ask you that for this particular set, what would your answer be? What are the numbers that are in A and B? So you told me A was 1, 3, 5, 7, 9, and B is 1, 2, 3, 4. What numbers are in both sets?
1 and 3.
1 and 3. So the intersection is 1 and 3. That is different from this. What does that mean? Yeah, but do you know what the letter means? No, it's union.
I don't remember that.
Well, it sounds like your math teacher really let you down last semester then. Elements that are,
I don't remember it either.
I don't know who y'all's math teacher was, but it sounds like an embarrassing dude. Or embarrassing lady.
It was you.
I don't think so.
I was here last semester.
It couldn't have been me. Must have been somebody else. That's elements that are in A or B or both, meaning they could be in both of them, or they could just be in one or the other. So in this case, what would be the union of A or B? Meaning what numbers are in A or B or both A and B?
All of them.
So no, not all of them, because A was 1, 3, 5, 7, 9, and B is 1, 2, 3, 4. So we got 1, 2, 3, 4, 5, 7, 9.
So all of them.
Okay.
Yeah, pretty much.
No, that's not all the numbers.
Well, no,
That
but
are
I
in-
meant
that
like
are in
all of
there.
them that are in both.
Oh yeah, you're exactly right. It's all the numbers that are in both. That's exactly right. You're basically just mashing the two sets together. Sorry, I thought you meant all the numbers,
No.
Right.
which would be a lot because there's a bunch of numbers. Okay, this is where compound comes from in compound inequalities. This symbol right here, the English word for that symbol is and. What's all the stuff that's in A and B? And this symbol right here means or. What's all the stuff that's in A or B? And means only the stuff that they have in common. Or means mash them together, it's everything included. These words and or are going to come up over and over and over again as we do compound inequalities. You will be seeing lots of and or. You kids are probably too young to remember when you'd go to the grocery store and they'd ask if you wanted your groceries bagged up with paper or plastic.
You did that in Austin.
Yeah?
They still do that.
Paper or plastic?
And also-
And your answer to that question should be
I don't care.
I got my
Yes.
own bags.
yes. I would like paper or plastic. It was a simpler time. Simpler time. Okay, so let me show you why we went on this detour reviewing sets, or I guess in some cases, seeing what sets look like for the first time. Let me show you what a compound inequality looks like.
Does that mean we suck as students?
Well, it doesn't mean that I suck as a teacher, so, I mean, draw your own conclusions.
The three of us were in the same class and don't remember.
I know, I can't believe all three of you were in the same
No,
class and not
that
one
was
of you
not in that
remembers the
class.
incredibly high-quality education I gave you on inequalities and sets. It hurts my feelings, honestly.
It would make
We
sense
must have
that
all been out that one day.
Mm-hmm.
I did miss a day.
Well, your
last year.
attendance isn't the best,
I
so.
think I missed one.
This year it's not.
Okay, so I'm sure, even if you don't remember sets, that you remember how to solve these inequalities, right?
No.
Inequalities function almost exactly the same as solving equations. So if I start with the x minus 7 less than 2 and I want to solve that, it means get x by itself. So I would just add 7 to both sides. And I get x is less than 2. Okay? One of the things that we learned how...
9.
Don't you mean 9?
No, I mean 9. That's what I said the first time. Pay attention. So what we learned last semester is how to graph these.
Oh god, do we have to do this?
Do you have to do? I mean, you don't have to do
Well,
anything.
that's not as bad as like graphing.
Not as bad as graphing, but good news. We're going to do some of that later this evening too. Okay, do you remember how to graph these?
Yes.
What do you do?
It's like a line.
It's less than, so.
If it doesn't
It's
have
less
a line,
than, so it goes from 9 down, right?
But the circle
Oh.
is open.
Yeah.
We're actually going to use, yeah, open circle, we're actually going to use the curve though. We're actually going to use the
At
parenthesis.
9, use the curve.
So what this means is numbers from negative infinity up to 9.
And 7 is circles.
No, not. If you were going to do the circles, it'd be circle on 9. There's nothing wrong with circle notation. We're just not going to do it. But the circle, like open circle on 9, that would be fine. I'm going to use the parenthesis, but you do what you like. Okay?
And then the infinity.
Now, this is every number that's lower than 9. So the way we write this in interval notation are the numbers from negative infinity to 9. Okay. Let's go solve the other one. Okay. So we will subtract 1 on both sides. And that gives me 2x is less than 8. And then I'm going to divide by 2. Stop spoiling the ending.
The fact that I know that is okay.
Darth Vader's Luke's father.
Oh, man.
Not so funny when somebody spoils the ending for you, is it? Bruce Willis was dead the whole time. Kevin Spacey is Kaiser Soze, and Rosebud was his sled. I hope you're happy. Let's graph this one.
6 cents is one of those.
I'm going to miss you. If I pass this class.
So you're not going to miss me? X is less than 4. So this is all the numbers 4 and below. So parenthesis on 4 with a line going down. Less than 4. This would be negative infinity to 4 in my interval notation. Okay.
Okay, cool.
Now the problem says to graph the compound inequality x minus 7 is less than 2 and 2x plus 1 is less than 9. Meaning my final answer is going to be a number line and some interval notation that includes only the part that they have in common. This is all the numbers 9 and below. So 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, down to negative infinity. This is the same thing but starting at 4 and working your way down. What's the part where they would overlap? If I picked these up and put them one on top of the other, what would both of them have?
4, 3,
4
2,
down.
4 down.
So that's what my answer is going to be. From 4 down. Which I could write in interval notation as negative infinity to 4. The part that they have in common. Both of those include all the numbers from 4 down. This one includes more numbers. It includes all the numbers from 4 to 9, or 4 to just below 9. This one doesn't, though.
I just totally screwed up that infinity sign.
It's okay. Nobody's going to see your paper except for you.
I don't even know
Trade
that.
papers, I wasn't really.
Yeah, that's probably a lot easier.
Nobody will see it except for you. Unless you come put it under this camera, and then my tens of YouTube subscribers will see it too.
Unfollow you.
Un-
Unsubscribe you.
As soon as they see your infinity, they're going to be like, no thanks. I was already on the fence about these math videos, but this clinched it. I'm out. I'm going back to Let's Play Fortnite or whatever you kids watch these days on the internet. All right, next one.
She's here.
Excuse me, miss, do you have a tardy pass?
I
It's fine. This is only the 6th week of class. You might have forgotten where the building was.
don't. Is this really the 6th?
7th? I don't know. Time flies when I'm with you.
Oh, that's so fun.
All right, here's Here's another and one, so let's go ahead and solve these. Yeah, it's because you're so fun. There's no place I'd rather be than doing math with you. So 0 divided by 2 is 0. So there we go. Let's draw our number line with 0 in the middle. Now, there's going to be a difference when I graph this one from the last two. A couple of differences, actually. What's the first one?
It's equal to.
It's equal to, so what's the symbol for that?
A closed circle.
It would be a closed circle, but since we're doing parentheses, this one's a bracket. And it's greater than, which means the line goes this way. I am now realizing that gray on black was not the smartest thing I've ever done, but there it is. Okay, let's come over here and do this one. So, add 1, that seems like a good plan. And we get x is less than or equal to -2. All right, here we go. So the number's -2, that's what I'll put in the middle. Like so. Bracket or parenthesis on the -2? Bracket on the -2. And is the line going to go up or down?
Yeah.
Down because it's less than. So bracket down. And just to make the whole thing complete, let's do our interval notation. There's that one. And there's that one. Real quick, this is another refresher, I hope.
Parentheses on this
Why do we always put parentheses on the infinity and negative infinity?
What?
We always put a parenthesis on infinity and negative infinity.
It goes on forever.
That's not why we do a parenthesis, though. What does the bracket mean?
It's equal to.
That's equal
It
to.
stops,
So
right?
why can't we put a bracket on infinity?
It's not equal to.
Because you can't equal infinity. It's not a number. So always a parenthesis on infinity. Cool. So now let's answer the question, where do they overlap?
They know.
They do not. So this is the saddest number line of all. There's no lines at all because they never overlap. What do I write for the notation then? How do I say what the overlap is? If there's not any.
No solution.
No solution.
Yeah, there is no solution, but we have a special symbol for it called the null set or the empty set. It's a circle with a line through it.
Alright.
Circle with the line through it means there are no solutions or empty set, or you may not eat donuts here.
That's just wrong.
Yeah. Yeah, we don't, those businesses fail pretty quick. We don't patronize those places. Who doesn't like donuts? I'm not sure I would trust a person that didn't like donuts.
Except for you get them.
You would like to be dropped from this class right now? Is that what you were about to say?
No.
I really don't need this math credit, so I'm going to take a stand on donuts. Is that what was about to come out of your mouth?
No, but I hate donuts more than anything in the world.
So that is what you were saying.
Yes, seriously, I hate donuts.
Really?
Yes.
More than anything?
Like, they make me sick.
More than that.
Yes.
Wow. So when you hear somebody talk about the Holocaust, you're like, man, that's awful, but at least it's not a donut.
Yeah.
Wow. That is upsetting. Like, I have bad news. Your friend has cancer, and you're like, oh God, at least they didn't eat a donut. It could have been real bad. All right. How do I do this?
You're gonna show us.
I want to get x by itself, so I gotta do -4, right? So the x is by itself.
But it wouldn't really be by itself. 'Cause we still got.
Right, but before we deal with the negative,
Which I
I'm supposed to subtract 4 on both sides of the inequality, but this inequality has like 3 sides. It's got like left, middle, and right. So where's the other place I subtract
Are
4?
you supposed to choose?
Nope, I do all of them. It's choosing where to subtract the 4 is like choosing your favorite child. Don't make me do it. You're all my.
His name is William.
Oh my. No! This is going on the internet. He might see it.
All my kids know.
Is that the hot one?
You have a hot one?
All right.
Yes, the hot
Let's
one.
see. Oh.
So you said that after subtracting 4, calm down, ladies. If you want to see a hot guy, your math teacher's right here.
You calm down.
If you said x isn't by itself, and you're right, because there's a negative sign in front. So how do I get rid of that? Just make it positive. Alas, we cannot just change things because we feel like it.
You can't add X. Can you add X?
Adding x would be bad, but you are correct. Dividing by -1 is an excellent idea because a negative divided by a negative is a positive. But just like with the -4, I got to divide everything by -1. And now here's where I'm going to test whether or not you remember your inequality rules.
Oh, wow.
When you divide by a negative, all the symbols switch.
Holy crap.
Divide, oh, which means I should have actually written them in the opposite direction.
I'm
When you
so
divide,
wait a minute.
I swear.
Oh, they switch?
What is up with
When
these
you
things?
divide by a negative, stop giving me a hard time. When you divide by a negative, all the symbols switch, or I'll rewrite it, you bunch of whiners. Jeez, you make 4 little mistakes, and all of a sudden people are like, hey, you don't really know math. There we go.
Wait. I was distracted. So,
When you divide by a negative, all of
Here,
yeah.
notice.
why are you? Oh.
That's a boo-boo.
That's everybody makes mistakes.
Even Mr. Perfect over here.
Even Mr. Perfect
7
makes
minus
mistakes.
3.
So this is what this is saying. I can actually,
Oh, no.
I can switch the order here. It would make a little more sense. This is what I was thinking when I was writing this, is if you switch it with the negative on the left and the positive on the right, that makes a little more sense. We're saying x is bigger than -3, but it's less than 2.
So we're
You're
switching it back.
confusing me.
Huh?
Are we switching it back?
No,
Like
I-
No, I switched the numbers.
yeah, you also
You
switch
switched
And you
the
switched the
symbols.
The
Yeah, I
symbols
did.
as well.
I did. I think writing it this way makes more sense than writing it this way. But these are exactly the same thing.
Okay.
These mean the same thing. X is bigger than -3, but it's less than 2. To me, it makes more sense to flip the whole thing so that the low number's on the left and the big number's on the right, but these are the same.
Okay.
So what does that mean? I have to write a really long number line now because it's got to include both -3 and +2. There it is. And I want to show that x is all the numbers in between -3 and 2. These are not equal to lines. There's no equal to there, so I'm going to use parentheses. So I put a parenthesis on 3. I put a parenthesis on 2, and it's all the numbers in between 3 and 2. So in my interval notation, it looks like that.
But it's less than -3.
It's greater than
Greater
-3,
than -3.
but less than 2. It's in between -3 and +2.
So should there be a bracket on the 2?
No, because there's no equal to lines. The
Oh.
brackets are when it's equal to. All right. Hey, you know it would be really fun.
If this was a word.
Would that be fun?
Yeah.
You have a low threshold for fun. This meaning class, or this meaning just like life in general?
I missed math class so much, I watched the accountant the other day.
Aw,
That's
What
a
a-
good movie, though.
what a great movie. I really identify with the main character.
Yes, you did. I missed you so much, I had to watch it.
Oh, good. Anyway, as I was saying, what might be fun is if we did one with fractions, because I know everybody likes those. I know they're my favorites.
I can't think of anything more fun right now.
Yeah, but you also couldn't think of anything worse than donuts. You don't have like the best imagination. All right. Well, the first step is obvious. We got to add 1.
Is it obvious?
If you know nothing else about this problem, you should at least get the add 1. Like that. So the problem now with the x is that it's being divided by 2. What do I do to get rid of that? Right, and as with everything else, I got to multiply it all by 2. So the first number, the second, and the third, all multiplied by 2. Now, I don't have to flip the signs this time because I'm not multiplying by a negative. Multiplying's fine, just don't multiply by a negative. So this one is all the numbers from -6 to +8. I assume by this point you're all kind of getting the idea on the number line, I hope, because I don't really want to draw a number line for this, because going from -6 to 8 is a gargantuan number line. So instead, I'm just going to do the interval notation. It goes from -6 to 8. Will I have parentheses or brackets?
I want to see the parentheses of brackets, thank you very much.
Brackets on both. Yep, like that.
Don't go nowhere.
Because they were equal to? Equal to means brackets. The equal to line is the orthodontist of the inequality world. It adds brackets. Right? Right, guys? Because that's when you get braces. Well, clearly you do not appreciate good jokes.
When I rewatch these videos at home, I literally die laughing. Like I
You-
only do it to hear your jokes. I'm
You
like,
literally die.
I die
Mhm.
every
Wow. Who is your English teacher?
time.
You literally die?
Well, I did go to Lando.
I didn't say that. All right. So all these problems so far have been the and variety, the intersections. Let's do some OR problems. We talked about the union, how the union is an OR problem. That U symbol for union means OR.
Both.
It means OR, and the union also Civil War champs. This is one problem. Separated by the word or.
Or is it?
You're very funny
I know.
looking.
I can agree with that.
All right, just like OR doesn't change anything at the beginning. Just like the last couple, our goal is to get the x by itself. So we're going to solve this sign. So we'll add 3. That'll give me 5x less than or equal to 13. And then divide by 5. 13 divided by 5 is something awful. You can leave it as 13 over 5. Or if you're really crazy, you could turn that into a decimal. If you prefer the decimals, it'd be 2.6. If you divided that out on the calculator, I don't care. You can pick your favorite.
But if we have to put it
How
on
is
the line,
piercing gonna want it?
Yeah.
It doesn't matter. It's the same. I prefer fractions, but those are the same number. It doesn't matter. Don't let anybody tell you how you have to write numbers.
Well, that math lab tries to do it all the time.
That math lab.
I know.
Let's solve this one. This one's really easy. Just subtract 1 on both sides and we're done. That one's easy. So my hope is that eventually you'll get to the point where you can do these problems without actually writing the number lines, because the number lines do take kind of a long time. But if you ever get confused, the number lines are a great way to go. So this is greater than or equal to 4. So there's our number line. It's greater than or equal to, so bracket for equal to, and greater than means it goes up. And then this one, 2.6, or 13/5, or 2 6/10. I'm gonna do like 2, 3. I'm gonna just do whole numbers on my number line here, but then 2.6 would be here-ish. And it's less than 2.6, so go this way. And then, because we are consummate math professionals, we'll go ahead and drop interval notation on there just to make the whole thing complete, because why would you not? Why would you not want to do this other than to save yourself time and misery? Okay, there we go. Now here's the question. That looks weird.
X.
I don't know why my 4 looks like an X. That's a 4.
Ah,
I'm really nailing it today.
number 5.
That's a 4. Good gracious. I'm having a hard time with the writing today. If I have some kind of brain aneurysm and I die, tell my wife she was one of my top 10 favorite people. So the question for OR is not what do they have in common. The question for OR is if I smash these together, what would they have? So this one goes from negative infinity to 2.6. This one goes from 4 to infinity.
Nothing.
Yeah, they don't have anything in common, but that's not what OR means. OR means if I smashed them together, what would it look like?
Oh.
It looks like it goes from negative infinity to positive infinity with a tiny little break. It breaks at 2.6 and it picks up again at 4. If you imagine me taking this orange line and putting it on this number line,
Oh, okay.
it would pick up right here at 4 and go on to infinity, right? So I'm missing this gap right here. So I want to say that it goes from negative infinity to 2.6, skips a little bit, and then goes from 4 on to infinity. How do I write that? Yeah, I do the little union thing. So literally it's these two things with a U in between, like so. The first one went from negative infinity to positive 2.6. The second one went from 4 to positive infinity, and I'm going to put a U here for union. There it is. And that is pretty outstanding. I know, I like it too. Let's do one more compound inequality. I want to show you one more special case. So let's do those. All right, help me out. What do I do first?
Add 2.
Add 2, that's a good idea. So over here, I'll do negative 3x minus 2 greater than negative 8, and I'll go ahead and add 2 on both sides. So that gives me negative 3x is greater than negative 6. Huh? Divided by negative 3. It gives me x is greater than 2.
So you don't flip the sign?
Oh, crap.
Ah.
What is wrong with me? X is less than...
Divide by negative numbers.
If you divide by a negative, you flip the sign. I swear I've taught this before.
And if you
Are you sure?
Yeah, I actually taught this last week to the Tuesday class. You'd think I'd know, but no. I'm sorry, you're not my one and only. You're number one in my heart.
Wait, you gotta give them all double.
I know.
We're rattling.
I know, I get mixed up. I'm like, how do you not know this? I just taught it to you. I'm like, oh, right, the different class. This one's really easy. We'll divide both sides by 5. Since we're dividing by a positive, no need to flip the signs. And 0 divided by 5 is 0. Okay. So, x is greater than 0 means we go from 0 on up to infinity. I'm going to try to do this without the number line to see if you can do it. X less than negative 2 means from negative infinity up to 2. So the question is, where do these overlap? This one goes from negative infinity to 2, and then this one picks up at 0 and goes to infinity.
so like 1 and 2 or 0 to 2, yeah.
There's a gap, not from 0 to 2 though,
0 down.
because this one goes to 2 and this one goes to 0. So if I were to make my number line, this would go like negative 2, negative 1, 0, 1, 2, 3. Okay, this one right here, from negative infinity to 2, goes here. That's that one.
And 0 to 0, there's not.
And 0 to infinity goes from 0
That way.
to infinity. They actually overlap. So there are no breaks in this graph. There are no breaks at all from 2 to 0. So what is the answer?
The donut with the line drawn in it.
No, it's the opposite of the donut with the line in it.
A circle.
That's not the opposite.
Wait, what?
The no donuts here symbol means no answers, no solutions, empty set. This is all the numbers from negative infinity to positive infinity. This is the opposite of no donuts. This is
All
donuts
donuts.
welcome, only donuts. Look, we got like 4 donuts in a row. All the donuts. 4 donuts.
Those are called twists.
That is not true. That is no.
Bro.